Good morning. I just wanted to discuss a routing issue with posturing and FTD VPN. This issue arose when there was a data interface named management on the firepower device, and then there's also the inside zone. In this particular scenario, the lab that I mocked up looks like this video. I've got a firepower device acting as a VPN gateway. Its gigabit 00 is connecting to the outside world. Its G01 is connected to the inside of the network. And its G03 is directly on the management network. The issue with this configuration comes up when the laptop VPNs in and it needs to posture to check its compliance. The initial connection works because the VPN gateway is directly connected to the management network where I have my ICE. So it can talk to ICE back and forth to authenticate the VPN user. The problem is, after the VPN user is authenticated, then the laptop wants to talk to ICE. So this laptop, or in my case, it's actually a virtual PC in my ESX cluster. He's going to then say, okay, I'm sending all my traffic through my default gateway, which is the VPN concentrator. That's going to then, the VPN is going to see a specific route to get to ICE, which is going to go through G03, through its data management. It gets to ICE, and then ICE is going to say, okay, now I'm going to respond to this laptop, and the destination IP is the laptop's IP. It's not going to respond directly on G03 because he's going to say, okay, this address for the laptop, like 172.16.1.20, that's not on my network, so I'm going to send it to my default gateway, which is over here. The default gateway sends it through the switch and in the G01 interface of the VPN gateway. The problem with this is the VPN gateway is also a stateful firewall, and it says, wait a minute, I'm getting traffic on G01 that I wasn't anticipating getting. So when it sees this traffic on G01, it says, this doesn't match any state of anything that came the other way, and I'm just going to drop this reply. Let's see if I can spin this up. So right here are my interfaces. I want to go into my devices, and I want to start a packet capture. To get a packet capture on a VPN or on a firepower device, go into device management, troubleshooting. And I have to be patient because this is a virtual machine with very few resources. Advanced troubleshooting. Capture with trace. And the with trace is what really helps us out here. This is more than just a packet capture. This is telling us information about what the firepower device does with it. So I'm going to call this one my inside. And it's going to be what traffic is sent on the inside interface. I can put source and destination networks. I probably should to help me weed through the traffic. But so on the inside, we're going to be getting traffic that's going to be coming from my ICE host, which is 172.21.25. And let's add another capture. I call it management because it's going to be on my management interface, and I'm going to select interface management. And again, I call this management, but it's a data interface. If you want to be able to use posturing and dynamic authorization with radius, the traffic has to go through a data interface. It can't be an out-of-band management interface. All right, so now through management, my source, let's just say my destination is going to be 172.21.25. This might capture some other management traffic, but between the firepower device and ICE, but that's fine. All right, so I should have my capture started here, and they're capturing. I'm going to go over to my management workstation, and I'm going to attempt to connect. I should be able to connect here because radius is all working between the firepower and ICE, but it should be able to not be able to find the posture server. policy server. So it's searching for policy server. It comes up with this attempted redirect. So let's go back over here and see if I can refresh. I'm going to refresh my capture. And I'm going to change this to tree mode just because I like tree mode. I see traffic going, here we go. So 172.16.2.20, that's my VPN client network. And it's sending stuff out, and it's just sending stuff. It doesn't ever build up a connection. So we're seeing stuff being sent, but we don't see this cool folder where we have all these phases. In this example, we're seeing, okay, from 172.21.25 to 172.21.22 on UDP 168, like what's all the flow? And it's actually showing how it's going through access lists and flow lookups, and eventually it allows it. In this particular case, 1.22 is the in-band management interface of my firepower device. But here we see the client is sending stuff here and nothing's coming back. Now I go over to the inside interface. And let's take a look at what we got here. So in the inside interface, we have traffic going from 172.21.25, which is my ICE, to the client. And this has a little folder. And look at the result here. It's drop. Why is it dropped? Drop reason, TCP not a SYN, first TCP packet not a SYN. So the TCP SYN was sent on the management interface, but then the ACK was sent, the acknowledgement was sent up to an inside interface. The Firepower stateful check said that doesn't work out for me, and it just drops the packet. So two solutions. The cleaner solution I wrote and tested was, well, the cleanest solution would be actually to get the management interface off of the direct connection on Firepower and have everything go through this router and use access lists to protect your management network. If you do it this way, then you won't have this management interface directly connected here, and all traffic will just go to the inside zone. Which brings me to another point that I'm not going to cover too much in depth, but when you have this connected here, you've got this data plane connection directly to your management network. You want to make sure you have access lists, when your downloadable access lists that you're pushing on the VPN client to protect your management network. You don't want your VPN client having direct access to the management network. So in my first solution, I used the inside router. And I'm not going to demonstrate this one, but I'm going to say show run pipe include route map. Oops, let's do section. So I created an access list. Called ICE, and it said it came from ICE, and it's heading to that client network. Oh yeah, I made a lot of typos when I set this up. Only one of them was actually valid, and I didn't get rid of the rest. So it should be the 172.16.2.0 is the only valid one, and 10 and 30 should be removed. But the logic is still valid. When it matches this IP coming from ICE, going to the client network, change the next hop, and it said, okay, the next hop is going to be 172.21.22, which is my G03 interface on my VPN concentrator. So this used to be applied to my G3 interface on this, but I removed it so I could demonstrate something else. So if I go back to my drawing, basically what that would be doing is it's going to get something that comes in through this management network, gets to ICE. ICE is going to send it to its default gateway right here. And its default gateway is going to say, oh, this matches the route map because it came from ICE and it's destined to this VPN network. I'm not routing it through my normal routing. I'm going to then send it back up to this interface. Again, the problem with that is, even though this solution is nice and I don't have to deal with configuring route maps on Firepower, it makes a wide open connection from the client to the management network unless you put in downloadable ACLs as part of your policy that you push from ICE. So the next solution, which puts everything on the firewall, is to create a FlexConfig with a route map. My personal preference is if I can avoid a FlexConfig at all, I will do everything I can to not have to FlexConfig. So to do a FlexConfig, go into Object, Object Management, Step 1 is create the ACL. I already created the ACL. I called it PBR underscore ACL. So in this ACL, I'm taking traffic that's going to be coming from my client VPN. I created an object called client VPN that matches the allowed address pool. And I'm going to send this to, and when it's a destination of ICE, it permits it on the ACL. Anything else that gets denied. And then I create a route map. And I called my route map keep on data. So that meant to me just keep on the data network. In 6.4, there's only so much you can do in route maps before you get to the FlexConfig. These are really meant for redistributing routing protocols, and they're not meant for policy-based routing. So I created my route map called keep on data, and I added a sequence. And my sequence here said match the IP addresses defined in PBR ACL. So far, this is very much like how you configure policy-based routing on a router or on a legacy ASA. If you see next hop, that might try to confuse you. But when you look at this, you'll say, wait, this doesn't make sense. This isn't setting my next hop. This next hop here is not to set the next hop. This is for matches in the route map. So this is for saying if the next hop was this, do something to it. We don't want that. So I've created my extended access list. I've referenced it in a route map. And now I need to go to a FlexConfig object. They have some PBR templates created for you. You can use variables if you want to make this very scalable, but if it's just a one-off, you're never going to, and you're never going to do any other one, you can define everything directly in the route map. Correct? Yeah. So FlexConfig object. And I already created one here called PBR. Actually, I created two because one had variables and one didn't. So this is a very simple one. Oh, this is the one with variables, sorry. But that's fine. As one variable, you can also make variables for the next hop. You can make variables for the interface. And then when you deploy policies, you can say, okay, when I deploy the policy this time, I'm using these variables for this firepower, for this instance. And you just kind of be very flexible about how you want to deploy it. So in this one, I say route map, and this is the variable for keep on data, and the value of this variable is keep on data. And I could change this if I had a different route map I wanted to use. And I'm permitting 10, and I'm setting the IP next hop. This IP next hop is the inside interface of my router here. So if you see 172.1642.5, and when I say inside interface, I've kind of misstated that. It's the interface that's inside the network. It's on my inside router, but it is the interface facing out to the firewall and VPN concentrator. So 42.5 is now going to be the next hop. And actually, I accidentally clicked on this, but you see it never found the policy server. I'm going to disconnect because it's not really doing anything. And back to the firepower. So this is my PBR FlexConfig object. Now that I have that object, I'm going to go to Devices, FlexConfig. Now I got to create a policy. So my new policy is going to include the VPN, and I'm going to call it PBR. And let's save it. Now I'm going to add my PBR next hop object. It has this nice preview button, but the preview button won't do anything until after you save. So let's hit save. And now I hit preview and see what is it really going to do and pick VPN. So it's going to grab policy about the VPN, everything you configured, and then append on this object I created. at some point. While it's thinking about its life, I want to grab my CLI session. Oh, there we go. And I'm going to go into the system support diagnostic CLI. This is pretty much going into the old ASA CLI. You can't really configure anything in here, but you can do all the show commands. A lot of show commands will work from the firepower prompt, but not everything. There are certain things that just mess up. So if you go into system support diagnostic CLI, it'll help you quite a bit. So if I do show route-map, there's nothing in there. So let's see, policy, route, nothing in there. Show run route-map. All right, nothing in there. So just keep that in mind. And so here we're saying, okay, we have configuration objects that we grabbed from, that were part of the configuration that it was naturally going to push. And then we're adding onto it route map, keep on data, set the IP next hop, and then we apply it to an interface. Kind of concerned with some of this extra stuff that isn't always on there. I might have made a typo. I'm going to remove this one just because when I tested it, I used this one. And let's save this and preview again. All right, there we go. This looks a lot better. So now you can see it actually built up the object group, everything I needed. It has the objects for client VPN. It creates the access list. And this is all stuff I configured through the GUI that it knew it needed. And then when we get down here, it adds on this piece for the IP next hop. The route map has already been created up here and did the match because we did that through the web interface. The part we added was setting the next hop and adding it to the interface. So let's deploy this. This is 6.4, so even though we're only deploying like a couple lines, it's going to take a while. This warns us that there's not extensive error checking when you deploy FlexConfig. You can seriously break some things with FlexConfig, and sometimes you'll push something and it'll reject it. Sometimes you'll push something and it won't reject it, but it just won't do what you wanted. So this is just the way that we push configuration for things that aren't supported on the graphic interface yet. It can be kind of interesting because you might want to say, I'm just going to do the entire policy-based routing. I just want to take a snippet of code and that I took from my legacy ASA and copy it right into the FlexConfig. I want to create the route map, the access list, everything, and do everything just through the FlexConfig. The problem is it won't allow you to do that sorry, it won't allow you to do that if it's something that's supported in the GUI. It only allows you to use FlexConfig if it's not on the supported on the GUI. All right, so now I ran this, and let's go ahead and see if it really deployed. Let's just show run route map. Hey, look, it's both there. Show run policy map. All right, so we do have a policy map and a route map. Now I'm going to go to my management workstation and try to connect again. Got my banner. This meets everyone's criteria, I think. Now it's searching for policy server. It says it's connected. Let's go and see. Oh, it's scanning my system. It found the policy server. And it still has this nice little redirect. I can pretty much ignore this. for the client provisioning redirect because it's scanning compliant access allowed. And what do you know? Now I'm up and running and I'm going to the default web page here. So I'm going to go ahead and close out this video and call it a day.